Hello everyone, this is Bradley. Recently people asked me about stylized explosion things he saw on Twitter or Instagram. I think it's very interesting, so I tried it by myself. Just so you know that I'm not a specialist in stylized art. I'm rather the kind of person who would like to hire those stylized artists for my project. But anyway, so let's start. So here we're in Blender. As always, I'm going to use the presets which you can download for free from the link in the description. So here I'm basically going to start with a UV sphere. Or actually I would like to start with an icosphere, but we will discuss it later. The basic concept for this kind of stylized art in older tutorials is basically you use a displacement modifier. And once you have displacement modifier, you generate the texture. And this texture will be Voronoi texture. Voronoi. And there is a mode called distance squared. Okay. This is a very specific mode. It does not present in our Voronoi texture. You won't be able to find that anywhere. I don't know why, but this is the case. Anyway, so let's take a normal displacement, which is essentially just a set position, but you are offsetting on the normal. Okay, so we're using a value to control this displacement. And here I'm going to use a Voronoi 3D. So I put the distance into the displacement. I need a more amount of subdivision. So 64, 64, or 125, 125. Yes, you can see these kind of pointy edges. And it's really, really bad. And you can find it's kind of irregular to this entire geometry as well. Some part is sharper than the other, in my opinion. Yeah, this is very round, but this is very sharp. Anyway. So we are going to make that to round. So like kind of blobbing effect. So this is the distance square formula. I don't actually remember the formula at all. It has been so long and I'm not a person who invented that. So that's why we need a preset. Next, we just need to add more details by adding more displacements and more Voronoi. So on the top of original blobbing geometry, we're adding a second level of Voronoi. So we can keep the frequency ratio as 1 to 2, and the scale ratio maybe at 1 to 0.5. And I may also change this mid level, or sometimes it's tricky, but anyway. That's why I sometimes hate these kind of things, because it's just an issue of parameters that you tweak. Yeah, I think that this is fine. Anyway, just trying to create this kind of blobbing, whatever stuff should be fine. And let's take a set shade smooth. Okay. But here I want you to know one thing, that the scale of your initial object doesn't matter to the entire setup. If my UV sphere is like 6 meters large, then you see the displacement we set initially almost means nothing. Okay, so you need to be aware of this thing. And well, obviously I'm not going to control these 3 parameters separately. I want to use 1 parameter to control everything. So here I'm going to use an animate node. This is essentially just a scene time node with a frame linked to the map range, so that my start frame is 1, my end frame is, let's say, 50, and I'm outputting a value from 0 to 1. I'm going to clean up these ECs. And then I'm plugging this radius scale, and I want to keep these ratios, so divided by 2. So now if I play this animation, you can see this blobbing growth. Okay. A good part is that I can also remap with this float curve, something like that. Then you have this very fast explosion-like event. Okay. You can also remap 0 to 1, and to increase the default size of this UV sphere. Okay. Before I go into some more advanced geometries, we are going to add shaders, because I think it's a very important part of this stylized art. So let's add anyway. And it's very possible that you add multiple shaders, because you need a shader for fire, you need a shader for smoke, and you need a shader for other elements once we add all these kind of trails. But I want to simplify these setups and the tutorials, so I'm going to combine everything into one. The way we're going to do is, firstly, let's deal with the fire. So I need a shader to RGB, and I need a diffuse BSDF. What it does is that essentially it's giving a gradient. So you add a sun color. It gives you a gradient of light, and it doesn't look like anything, because a key feature of a stylized art is that you have a color ramp and you have a constant mapping of this light. So now you have these sharp edges, and this is what's giving the different results. And you can add one more layers. So this is the key. Okay. To me, it's kind of very annoying, because usually you have to remap these colors separately. But anyway, this is kind of case. Here, I also want to remind you that by default, I think starting from 4.0, your color management is set to AGX. A very important feature of AGX is that brighter it will be, more it will be desaturated. This is very realistic, but it's not really good for stylized art. So you either use a standard or you use a filmic. I will just make that to medium high contrast. Okay, and you can make that kind of high contrast, and you can keep these high contrasts even if you're blooming that out, compared to this AGX, which looks kind of very whitish. Okay, so this is kind of idea. You may also want to ask, why do I increase the strength instead of increasing this intensity? I think it's simply because this intensity is more of a global settings. That's why I don't usually like it. Here, I mainly want to make this entire shader like a smoke. So I'm going to delete this orange color, and I'm going to decrease the saturation and the value of the highlights part, so it becomes like a smoke. And then we work with the second shader. I'm going to make a rim light, or rim, whatever. Let's go with a color ramp, and this time make it very bright, and we have this kind of cutting edges. And I'm also going to call a Layerweight, which gives a facing value. You can actually compare these two. I think they are very similar. I don't consider them being very different. You can use whatever you want. the main point is that I need you to get a values. And now you can actually see, you can use linear. And by crushing this black area, you can see there's only a rim to be shown. And if I multiply these two values, let's take the color, then you can see this rim only shows from the part which is facing to our sunlight. And you can also make that into linear so that there will be a transition from appearing to disappearing, making it more natural. And then you take another color ramp to give it a color. So let's take an orange color. We can also make it a constant. Okay. And then we take the emission shader. So something like that. This is really just an example. But the entire point is that you create a rim of emission shader. I don't think I'm actually going to use that, but it's really just an example. And then we're going to create the third shader. The third shader will be just a noise texture. And it's not really black and white. So you need to increase the contrast of it by yourself. There's no way to really normalize that. So something like this should be enough. Okay, it's very possible that this color is out of range, like the black is negative value and the white may be positive 100 or whatever stuff. So you need to be careful with that. Sometimes you might want to use a clamp value. I'm not sure if there's difference, but anyway. Okay, so once we've done that, I'm going to color ramp that again, so that I'm creating this kind of fires, and you can increase and decrease its values. And we again put that into an emission shader. You can also increase or decrease the amount of details, roughness, and so on. This is up to your decision. And what you can do here is to mix these shaders. And what's the way of mixing? If you directly use an add shader, then you will see it looks kind of very bad. So we are going to make this blobbing into different sections based on its Voronoi identity. So if I visualize this Voronoi distance in solid mode, obviously it does not really give any numbers because this is negative due to this mid-level, but we can visualize the position. So we have these different sections, okay, and it will be more sections as you increase its scale because it's more subdivided later. So what we are going to do here is to store named attributes, to take a white noise, and this white noise will give a value for each blob, and I'm going to compare that to make it greater than. So if it's greater than certain values, then it will be selected for explosions, and then that's, yes, something like that. And you can see this edge is kind of very sharp. because this is a Boolean, we can blur attribute. And you set that to float. So that's the edge will be a little bit faded out. And we take that into a color. You can name whatever you want, whether it's A, B, C, D, E, F, G, but I'm going to name that as a C. And then I'll take an attribute C and put that into mix shader. And now if we go to render the view, this is what it looks like. You can tweak a lot of things, but here you may realize that one is very detailed with this noise texture, the other is kind of very flat with only a single color gradient. So we can add a noise texture to it. So here, let's take a mix multiply. I'm not sure if you can use the same noise texture. I think it's questionable. We can try. So anyway, let's take a contrast and let's increase the contrast and maybe decrease the brightness and make them to multiply. Okay. Something like that. So now you can see it becomes more irregular while retains some effect of this shader to RGB. And you can also increase the scale, so adding more details to the setup. But this is basically the idea. So now if we look at this entire setup, we can add a third level of this kind of coloring. Maybe we should just make the bright part a little bit sharp. So yeah, finally it looks like this, kind of ugly. And we can also add shader. Sometimes I don't really know what I'm doing. And you can see there's a ring being created on the edges. Maybe we should use a different noise texture. Maybe we should also decrease the amount of explosions or increase the frequencies of it. Maybe even decrease it. You may also increase the amount of subdivision surface. Okay. Something like that. So anyway, finally this is just this kind of whatever stuff. And if you increase the emission, which is also a kind of a process of mixing colors, then you have this kind of explosion occurs. And trying to change the frequencies of it. So now we have this kind of explosion event occurs. I'm not really satisfied with it. That's why I said I'm not a specialist to it. Essentially just trying to play around all these kind of settings. You get whatever you want. I also want to mention that this is more kind of a simplified version, because in a more complex setup, you can instance spheres on the top of this blob, so that instead of mixing different shaders into one, that you can have a separate shaders. But it will increase the complexity of these tutorials. I'm not going to do that. Okay. And then let's move on to trails. There are many different ways to make trails. And let's start with curvilinear. And I'm going to uncenter that to choose the z-axis. So it's just a straight line to the sky. And let's take a point instance geometry. Maybe I'm duplicating 10 curves and take a random rotation. So this is what we're having. You can also change the seed. Take a set position. Here, we're going to use a spline parameter, which is going from 0 at the start and the 1 to the end of a curve. We combine x, y, z, take it into the offset. We need to realize the instance so that all these kind of vertices are accessible. And immediately you can see, because we give a value of 1 at the end, so there's an elevation. If we remap that, use a float curve, then this is what we're seeing. And I'm going to remap this 0 to 1 relationship to make it going down. So this is to kind of simulate any event of gravity. So something is going downwards. Okay. And you can change the interpolations and the scale. You can also increase the count to make it a little bit smoother. Next, we are going to trim this curve. And by animating this end value from 0 to 1, you can see there is an animation of appearing and disappearing. And as you may think that we can use the same 0 to 1 animation to animate this value. So while this explosion is growing, we have these curves growing as well. So this is the idea. And then let's make that into a mesh by this bevel curve. That's increasing the resolution. We are also going to set curve radius. I'm going to set that after this trim curve, so that while it's a trim, then this radius is always 1 at the end of a curve. And then let's take this spline parameter. We can plug these spline parameters into the radius, and this is what you will see. So we're going to reverse this relationship. Just make that reverse 0 to 1. And then let's decrease the maximum radius. Maybe add a little bit of thickness at the end. And after that, take a normal displacement. This time we're going to use noise 3D. And let's increase in the frequencies, decrease the scales. And we need different materials. So let's rename that. So one is explosion. And let's name another materials. Let's name that as a trail. Here, let's change the explosion shader into the trail. And then let's go to shader editor again. We're just going with a very simple version of shader to RGB, diffuse BSDF, and we take a color ramp, make that into a constant. We take a grayish color. So this is what we are having. And I think this is You can tweak more and you can make that more complex using the techniques I've discussed earlier. And I think this is okay. So if now we join these two geometries, then you will see that there's, while it's exploding, there's a trail growing outside. Here you may realize that because this displacement with noise is applied to this entire thing, so this endpoint is a little bit bulging out. If you want to decrease the noise at the end, you can capture a spline parameter. And as you see, the end is 1. So we need to remap 0 to 1. And we need to reverse the relationship and plug that into the 4. So it becomes something like that. You can also color ramp it. So that the noise will be retained to a farther distance. And you can also increase the frequencies. And it goes to shaders. This is just an example. And then let's increasing the values. You can also use a randomness for the scales, but then it increases more amounts of nodes and so on. Okay. So something like this. We have this animation. And then we need to instance some whatever object at the end of these curves. It's kind of very basic. You just take a curve and we instance some points. And we take a, let's say, UV sphere. And I'm going to transform it to be more kind of straight version. And we probably want to scale that down, but I will do that later. Take the endpoint selection so that we only instance at the end. And it looks like whatever huge egg. We take alignment on splines. So it's oriented with our curve. And we scale that down. So now we can see actually there is a, it's a, how should I say, it's shooting like a bullet. But I think it's how it works in real life as well. We can take a set material. This time we are going to create the third shader and the emission shader. I don't know what to call that, just call that OBJ or whatever. Take a orange color and join geometry. Maybe 25, 125, and make that even smaller. You can also add a gradient of it based on UV map or other things, but I don't want to do it here. Okay. So this is sort of ideas. That's we made this explosion animation. And there are lots of things that you can tweak. For example, initially you may think this is a little bit too round. Then we can remap it to something else that we can have a larger explosions or larger displacement, and then it becomes even larger. So there are parameters that you can tweak. I don't want to spend much time for them in this tutorial. So this is a single unit. The good part of this entire thing is that we can use a single value to control this entire animation. And you realize this value going above 1 is not working because everything is being clamped by this float curve. That's why I made a preset of remap 0 to 1, so that to specifically work behind this kind of mapping. So now we have this animation. It also means that by manipulating these values, you can have a delay of different animation. For example, you can put that into a group input. You may put these values into a group input, so that when you duplicate different objects, they have different values. Let's just do that now. So we have a full explosion, but we also have a delayed explosion version, kind of things. Okay. So at the end, let's offset this entire animation. Whatever we are having here right now is a single unit of the explosion animation, and I've shown to you that this is controlled by just one parameter. So I'm just going to take a Control G to make that into a group node. There are several things I would like to expose. One thing is that different seeds, because I want to change the seed. So let's take an index seed in which we're using one seed to give multiple other seeds. So we have one seed for random rotation. We have the other seeds for Voronoi 3D. We have the third seed for Voronoi 3Ds. Are there any other random values? At the same side, I don't have it here. But you can really make the setup more complex, like making the random value of the scale, making the random value of the rotation, making the random value of the radius, and so on. There are so many things that you can change, but it will make things extremely complicated. And then I need to expose these values outside this group. I think this is it. So now we have this explosion unit, and we basically need to run a repeat zone to repeat multiple parts of it. So if I directly put a curve linear and instance some points, and I put this explosion unit into this geometry. So I take join geometry and put this into an instance. Let's only instance 5 times. And because I have domain size 5 for my curve, so point count 5, so I instance that 5 times. And I pick instance. So here, let's take a geometry to instance. So that I have 5 instances in total. Each will be instanced on a curve, a point of a curve. So this is what we're having. And I'm going to change the random seed in this case. So let's take a loop index. For every loop, this index is being +1, so that every time you have a different values, you can plug that into the seed, then you have variations of your instances. Here, I want to remind you that inside this explosion unit, there's a index seed. And here you may start to understand why it's called index seed. That we input an index, and we can have another seed to change the random seed for variations. So now we have this set up, but we can change the seed to make it 100% different. So everything is procedural. Okay, and next we are just going to offset these entire animations. It's kind of very simple. We take a delay for. I discussed this delay for many times when it's kind of a 3.0 era, and I made very minimal tutorials after that. But the concept is very simple. That's it's essentially an index node. And for a curve, we have first point index 0, and the second point, third point, fourth point, fifth point, and so on. Yes, we have 5 points in total. And you basically give each index a delay, like a 0.2 for each. Like we have 0 offsets, 0.2, 0.4, 0.6, 0.8, and so on and so forth. Okay, so this is the step interval for each index, and the duration for this fourth going from 0 to 1 is 25 frames. So this is the concept. And we basically just sample index with this loop index. So for every loop, actually we're generating a different numbers. We plug this curve, we put this into the fourth, and then we outputting this new value of resampled time. And now if we play this animation, it's not very obvious with the delay. Let's increase the step interval maybe to 5 frames. So after 5 frames, you will see the second animation is coming out. It should go into this direction, but somehow it's going that the opposite direction. In that case, either my preset is wrong or something is wrong with this join geometry. I don't think it's very obvious, but let's link it again. And you see it's going in the correct direction. Okay, and basically that's the part you can tweak parameters. For example, we step interval 5, duration 5. It means that it takes 5 frames to finish one animation, and then the second animation will come out, third animation, fourth animation, fifth animation, and so on. Okay. And since this is a procedural setup, you can make any other kinds of curve. You can even draw one, and you can import that. But I want to warn you that every geometry is actually a real geometry, and it's usually very dense when you do all this kind of detailed Voronoi animation. So you want to try to keep the count low. And then you have this kind of whatever. Okay. If you have a supercomputer, you can ignore what I've said. But I don't have a supercomputer. So this is basically it. Right now it already takes like 900 milliseconds for this animation. So this is it. So I hope you enjoy this tutorial. I'll probably see you next time. Bye bye.